Hi, my name is Wayne Carter. I'm Vice President of Engineering for Couchbase's embedded and edge computing products. In this talk, I'll show you how including edge computing in your digital transformation initiatives can simultaneously increase your business uptime, speed, and agility while decreasing architectural complexity. I'll discuss the technical options and architecture for building highly available and performant edge compute systems, and the details of how Couchbase can accelerate your ability to benefit from edge computing. I'll start by looking at the key benefits offered by edge computing, then I'll look at the capabilities of cloud and edge computing architectures, and finally, I'll show you how Couchbase is purpose-built for edge computing initiatives. Today, edge computing is a very popular topic. It promises consistent sub-10 millisecond and even sub-millisecond response times. Global high availability beyond 5 and 6 nines, even up to 100%. Virtually unlimited scalability, flexibility to grow and shrink with technical and business needs with little to no architectural changes, and the ability to defend and recover from a wide variety of security threats. Fundamentally, edge computing is an approach to system architecture that enables moving past the limitations imposed by traditional cloud architectures. Let's look at what this means and see why these edge computing claims are credible. This is a diagram of both cloud and edge compute, storage, and networking stacks. On the left is a cloud computing stack. It has two compute layers, one in the cloud and the other on the client, with devices accessing the cloud compute and storage via a wide area network. On the right is an edge computing stack. Like the cloud computing stack, it has two layers, one in the cloud and the other on the client, with the devices accessing the cloud, compute, and storage via a wide area network. And in addition, it has an optional edge data center that can provide intermediate compute and storage, with devices accessing these resources via a local area network, and a private area network that allows devices to communicate directly with each other. Adding some additional system components, in the cloud, there are fault-tolerant systems in a central data center and interconnected data centers connected by fiber. In the optional edge data center, there are additional fault-tolerant systems and IoT gateways connected to the cloud using fiber and wireless. We have a wide variety of devices, including phones, tablets, embedded systems, peripherals, and IoT, connected to the cloud, edge data center, and other devices using cellular, Wi-Fi, Bluetooth, RF, and Ethernet. Now, let's look at the capabilities of these architectures under fundamental real-world operating conditions. Starting with all systems green, every request is processed quickly and always returns a non-error response. Business is up and running at full speed. Taking network latencies into consideration, the top-end speed of the cloud computing system is primarily bound by the latency of the wide area network, delivering top speeds in the tens to hundreds of milliseconds per request. The edge computing system matches these speeds over the wide area network, but can reach faster speeds across its additional access paths, delivering 1 millisecond per request speeds over the local area network, sub-millisecond per request over the private area network, and microseconds per request for operations processed locally on the device. So under ideal operating conditions for both architectures, the edge computing system is strongly differentiated by its speed. When the cloud tier becomes less responsive due to network congestion, compute deficits, physical failure, or any other issue that impacts the responsiveness of the centralized cloud environment, the cloud computing system slows down. For business-critical systems, the result is business slowdown. Under the same conditions, the edge computing system speed is unaffected, and business continues as usual. When the cloud tier becomes unavailable, the cloud computing system stops working, and the result is business downtime. Under the same conditions, the edge computing system speed and availability remains unaffected, and there is no business impact. When the edge data center starts to slow down, we see our first impact. In this edge compute system, the IoT devices that depend on access to an IoT gateway will slow down, while the other parts of the system that only depend on local operations or operations across a private area network remain unaffected. When the edge data center becomes unavailable, the devices that depend on access stop working. parts of the system that only depend on local operations or operations across a private area network are unaffected. When the private area network becomes unavailable, the devices that depend on access stop working. In this edge compute system, the peripherals that depend on access to a companion device stop working, while the other parts of the system that only depend on local operations remain unaffected. Even under total failure of networked resources, the edge computing system can continue to operate. The key: local data and local compute. The parts of the system that have local data and compute can continue to operate under any condition, with edge data centers and privately networked devices providing the flexibility to tier networking and compute resources to tune for the individual speed and availability needs of varying business systems and components. And Couchbase is built to meet the requirements for edge computing at every tier. Let's take a look. So starting with an edge computing stack, how does Couchbase fit in? In the cloud, we have Couchbase Server, our highly scalable and performant distributed database server. It has key value, query, full text search, analytics, eventing, security, and low latency, high throughput synchronization for high availability in the cloud. In addition, we have Couchbase Sync Gateway, our web gateway for securely synchronizing data over the web with the ability to scale from hundreds to millions of concurrently connected devices and systems. On device, we have Couchbase Lite, our fully functional and performant embedded database. Like Couchbase Server, it has key value, query, full text search, analytics, eventing, security, and low latency, high throughput synchronization over wide, local, and private area networks for high availability on device. And in the edge data center, backing web, mobile, and IoT applications, you can heterogeneously deploy Couchbase Server, Sync Gateway, and Couchbase Lite to meet the speed, concurrency, and availability needs of individual locations in the system. And Couchbase can be deployed in any network topology, including star, tree, mesh, ring, line, hybrid, and any other network topology that you can think of in private, public, cross, and hybrid cloud environments. Let's look at Couchbase deployed in the edge computing stack from earlier. It has two compute layers, one in the cloud and the other on the client, with devices accessing the cloud via a wide area network. In addition, it has an edge data center to provide intermediate compute and storage, with devices accessing these resources via a local area network, and utilizing the private area network for direct device-to-device communication. In the cloud, fault-tolerant systems in a central data center and interconnected data centers are backed by Couchbase Server and Sync Gateway. In the edge data center, additional fault-tolerant systems are backed by Couchbase Server and Sync Gateway, and IoT gateways use Couchbase Lite. On device, the phones, tablets, and embedded systems use local Couchbase Lite databases. The peripherals connect to their companion devices using a private area network, and the IoT sensors connect to IoT gateways using the local area network and RF. All of the Couchbase databases synchronize using a hybrid topology, with star in the cloud, tree to the edge, and mesh between devices. Let's look at the capabilities starting with all systems green. Business is up and running at full speed, and database changes synchronize in real time. When the cloud tier becomes less responsive, the edge computing system speed is unaffected, and business continues as usual. When the cloud tier becomes unavailable, the edge computing system speed and availability remains unaffected, and there is no business impact. When the edge data center starts to slow down, we see our first impact. The IoT devices that depend on data from an IoT gateway slow down, while the other parts of the system that only depend on local data and data accessed over a private area network remain unaffected. When the edge data center becomes unavailable, the devices that depend on its data stop working. Parts of the system that only depend on local data or data access over a private area network are unaffected. When the private area network becomes unavailable, the devices that depend on data access over this network stop working, while the other parts of the system that only depend on local data remain unaffected. Even under total failure of networked resources, the edge computing system using Couchbase continues to operate at full speed, with databases deployed in the cloud, at the edge, and on device, enabling the ability to deliver tunable data availability and speed guarantees throughout the system. To recap, I've talked about how edge computing can simultaneously increase your business uptime, speed, and agility while decreasing architectural complexity, and showed how Couchbase's edge computing products can deliver guaranteed speed, high availability, scalability, flexibility, and security throughout your solutions, applications, and systems. Thank you for joining me today, and I can't wait to see what you create using the amazing capabilities of edge computing.